So, circumference and arc length. How do we find circumference? So, quick review. We need to know that in order, that background knowledge in order to function today. How do we find the circumference? Diamond, what do you got? What's that? Good. Yeah, we use CD pi. CD pi, eat d pi, right?
Isn't pi d?
Dude, you missed Mr. Vogel's joke there. CD pi, eat d pi. CD pi. Now, that's not what Diamond said. She said actually C equals pi d. Right? But if you think CD pi, eat d pi, that's a good way to remember it, dude. All right. What's another way of thinking about it? Rather than diameters, you have, yeah? 2 radius. So 2 pi r better than 1, right? 2 pi r. 2 pi are better than 1, dude. Unless you don't like pi. And that's not good. Jeez. Tough crowd, man. Julian? Man, come on. All right. So, CD pi and 2 pi r. All right. Those are our 2 ways to find circumference. Okay? Any questions? All right. With that being said, I want you now to spend the next 5 minutes or so working with your partner to complete A through D on page 100 or 314 of your student journal. Okay, I've heard three really good things. First, what should I round to? Nearest hundred. Round to the nearest hundred. So I want your actual answers in terms of pi and rounded to the nearest hundred. Many of you may not remember what in terms of pi means or know what in terms of pi means. It just means the pi symbol is in your answer. So I want your answer in terms of pi and rounded to the nearest hundred. So you'll get 2 answers. So you put what you think it is there. And then the other thing I heard is, dude, do I use 3.14 or do I use pi? You use the pi symbol. We're not using 3.14. Okay? And then the next thing I heard is, where is pi? Well, pi on a graphing calculator is right above the caret symbol, the little up arrow, right below clear. You need to use the shift or the second key and then push that button, and then you got pi. Dude, you hit enter. Hey, there it is. Right. Some good pi right there. All right. Okay, make sure you share it with the people around you. Okay? Make sure that you guys match up. All right. Let's see. Now, you're going to see me use, I like using this formula a lot today, 2 pi r. And there's a reason for it. Pi d is fine. It works as well. Remember, 2 radii, 2r, makes a diameter. So if you use pi d, that's fine. But I'm going to say my radius here is 4. So I guess I should zoom in there for us. Radius there is 4. And if that's 4, our circumference is 8 pi. Now, how many got 8 pi? Okay, very good. That is in terms of pi. That's one of your answers. You like in terms of pi because you're like, dude, I'm done. Now, if I tell you to round to the nearest hundredth, which I also told you to do, we now have the equal sign with nice hair, okay, also known as the approximate sign, okay, and we round it up to 25.13. All right. And both of those are linear units, right? It's still a straight line. It's like if I took a string and wrapped it around here, I have that whole thing. I'm using the whole circle in this one, the entire circle. How many got that? Okay. Any questions? Yeah? 8 pi. Radius is 4, so 2 radii is 8. So 2 times 4 is 8 times pi. Okay, or a diameter is 8. Hi.
Shouldn't you put the 2 in front of the r then?
They don't. That's just not how it's. I don't know. Well, it actually, you guys, the reason they don't do that is mathematically you put your numbers and then symbols that represent numbers and then variables. That's why they don't. But yeah, I mean, really, I'm thinking of it in my head as 2r pi. Right? Because that 2r is a d. I know. But then I couldn't say 2 pi are better than 1. Right? Because then it wouldn't make sense. Yeah. All right. Letter B. Letter B, well, the entire circle, this is the same size circle, right? The entire circle here, once again, has a circumference of 8 pi. But I don't want the entire circle. What part of it do I want? 1/4. Yeah. What do you get? So what'd you do?
Well, you have to use the 8 pi, and then you divide that by 4.
Okay, you divide it by 4. Is it okay if I multiply by 1/4? Good. So I'm going by the portion of the circle. Okay, and they tell you the 1/4, right? They say 1/4 of it, so I'm going to go times 1/4, which is the same thing as dividing by 4. That gives us 2 pi. 2 pi is approximately 6.28. All right. How many got that? Okay. Questions? Stuff too hard? Pretty easy? Yeah, easy so far. Okay, 1/3 of a circle. It's not 8 anymore, right? What's my radius this time?
2, 10,
5 is the radius, so C equals 2 pi r, which is, in this case, 10 pi. What are we multiplying it by? 10 pi times 1/3, which is?
10/3 pi.
Good. It's like having a fraction there. 10 pi times 1 is 10 pi. 1 times 3 is 3. So 10 pi over 3. And that's how we write that. We usually don't go 3 and 1/3 pi. Okay, we'll go in improper fraction. 10 pi over 3, which is the same thing as approximately. Okay, 10.47. Yeah. So enthusiastic about it, Maddie. Yes?
I just have a question. Why do you prefer that way?
This way right here?
The C equals 2.
You'll see. I promise I will show you why I keep going 2 pi r today. It's for when we go to radians later. It's just another way of measuring. Okay. Okay. I know it seems like it takes a lot longer, right? It's like adding an extra step. Trust me. I won't steer you wrong. It's good to know why. So radius here is 3. 2 pi r. Better than 1. Okay? C equals 2 pi r, which gives us 6 pi. And 6 pi times what this time? 5/8. And some of you are like, yuck, that's not fun. Can I cross cancel? Cross reduce?
Oh, yes.
Yeah. 8 and 6, what reduces? What goes into both? 2. So this becomes 3, and this is 4. So 15 pi's over 4. Yes.
Do you want us to always write it like that?
Always reduce. Yeah, always reduce. Approximately 11.78er. All right. Related to mater. Okay. Everyone rate themselves 1 to 5 right there. The good news for you is you've just come up with the formula for finding the arc length. Now please note the arc length is different than the arc measure. Arc length is a linear distance. Okay? This is a straight line distance. Well, I guess I shouldn't say straight line. It's a curved line, but it's a linear distance. Okay? It's a line. It's like if you took a string and lined it up there and then measured how long that string was. Okay? So a linear distance. All right? Now, that's arc length. Arc measure? Arc measure is a degree measure. It's saying, what is this in degrees? Now, like if I said, what's the measure, the arc measure of this? The measure of this arc, that's 90 degrees, right? Because the intercepted arc here is 90 degrees. Versus the arc length is 6.28. Okay, you guys with me on that? Yeah, man. Okay. Any questions? That is some fun stuff right there, I'll tell you. Okay. I know. Pure joy. So, what I want to do, let's go ahead and turn to page 316. Really, what you're doing here is you're summarizing a few things. First, you're defining what arc length is. You may have already done that somewhere else. Second, you're defining circumference. And third, we're going to define radians. Now, an awful lot of talking right now. Okay? Is everyone on this page? I skipped a page, didn't I? Yeah, that's okay. I skipped 315. Go to 316. So those of you on 315 and you're like, what's up with the motorcycle, man? Okay, that's not where I'm at. Okay, then go to page 316. All right, so I want to skip over to this. I want you to define circumference, arc length, and then we will go through what radians is, or radians are, and then they actually give you those formulas again down here. Okay, make yourselves any notes that you need as of right now. Okay, go for it. Okay, I want you to ignore radians for a minute. All right, now I want you to turn back to page 315. All right, now I know that's a lot of work. I made you go out of order there, but I wanted to give you a chance to summarize your notes before we go into this next exploration. Now you'll notice in your textbook, this is the same exploration that's on the bottom, page 593. Okay, it says work with a partner. You have this rider. It's attempting to stop the front tire of a motorcycle in that painted rectangular box for a skills test. See if he's got the skills or she's got the skills. The front tire makes exactly 1/2 of an additional revolution before stopping. Diameter of the tire is 25 inches. Is the front tire still in contact with the painted box? Explain. I want you to work on this top part right here. Do your best. Okay, you guys get about 4 minutes, 5 minutes or so. Hey, let's see if we've got a starting point. What are people doing?
I was trying to explain to Grace.
Chase? Finding the circumference of the tire. So what is the circumference of the tire?
78.54.
Okay, so in this case we get has a diameter 25. Okay, so that's 25 pi. And you said that rounds to 78.54. Is he correct? Yeah? All right. All right, so why do you find the circumference of the tire?
Because it's doing a half rotation, so we're going to need the circumference to divide it in half.
Okay, so you're going to take half of that? So half, I'm going to use, now when I'm taking half of something, I'm going to use the exact measure, which is 25 pi, and we're multiplying it by a half, because you only want half a rotation. So in other words, 25 pi over 2, or 12.5 pi, would be fine to write as well, since it terminates there. And that is approximately, anyone have that? 39.26? Set? Whoa. Dissension in the ranks. Okay. 9.27. All right. Okay. So we're saying your tire is going to go this far. Is that correct? So how do we figure out if they're going to stop? Yeah. Go for it.
Well, it's like you have to find out how long the box is, so it's 3 feet and that's 36 inches.
Okay, so we have, hold on one second. That's a big step. You have to convert that feet to inches because you're measuring inches here, right? Okay, so good call. All right, so then what? So really that's a good point. You're only allowed to travel that far and still be on the box. Okay? This person's traveled further than that. So will they still be there? Nope. They travel 3.27 inches too far. Dude. What a bummer. You fail, dude. You didn't, I know barely, but 3 inches, you know. That's a
How is
big,
that a skill test? Like, it's not that hard to roll a tire onto a pond.
right. I can't wait to watch Kira try to do it. Right, good. While it's moving. Like, you don't just get to move your feet and push it along. You got to be like driving it and stop it.
Oh, that would be hard enough.
It'd be a little more difficult. Okay, the answer is no. You travel 3.27 inches too far. All right.
Unless your tire is small and you have like a 6-foot box, then it'd be pretty.
Yeah?
That'd be kind of cool to try.
Okay, I want you guys to answer question 3 and 4 real quick. Summarize what we've done so far. Besides doing that, make sure you put that, since it says explain, you got to explain why. Even though you've done the math, make sure you say why. Grace?
When you're explaining, is it okay if you just say like that 3.927 is greater than 36 inches?
Yeah, that's fine. How can you find the length of the arc? Well, what do we do? Yeah?
You find the circumference and then just times it by whatever the fraction of the circle that you want.
Good. Find the circumference and then multiply it by the fraction of the circle. Now, the way we write that is we take the measure of whatever our arc is. So remember when we said we had 1/4 of a circle? Well, the measure of that arc is what? Let's go back. Yeah. So when we had 1/4 of our circle, the measure of this arc right here is actually 90 degrees, because it's the same as the measure of this arc. So 90 out of how many?
4.
How many degrees in a full circle?
360.
360. 90 out of 360 is?
1/4.
Yeah, it reduces to 1/4. So really, that's where we get the 1/4. All right? So if I had 180 out of 360, it would be?
2/4 or a half?
Yeah, 2/4 or a half of circle. Okay? What if I had 30 out of a 30-degree angle? 30 out of 360. Cancel zeros. 1/12 is right. Good job. All right, 1/12. Okay, so really what we're trying to do there is we are taking the measure of the arc and we're dividing it by 360. And that's giving us that fraction we're talking about. Whatever our arc is, divide by 360 times our circumference.
Huh.
All right.
Would you ever actually write out that equation?
Some of them. Would I actually write out that equation?
Yeah.
This? I probably wouldn't write that full thing out. I would write it out like we did in our other problems there. Okay, so motorcycle tire has a diameter of 24 inches. What's its circumference? Pi d, right? Which is? Okay, in terms of pi. Let's go in terms of pi, the quick way. 24 pi. All right. Okay. Approximately how many inches does a motorcycle travel when it makes 3/4 of a revolution? So your question, Kira, if I'm going 3/4, 24 pi times 3/4. That's how I'd write it out.
Oh. There. So you wouldn't actually have to find a measure of the arc, like the degrees?
Well, usually you would have this.
Usually give it
That's
to
how. Well, no, you would get this by doing that. We'll try it. We'll try it on a few problems. Okay, so this becomes 1. This becomes 6. The answer is 18 pi, which is approximately 56.55. All right. Hey, any questions? Okay. So what you have is we've went through, we've talked about, if you look at page 317, we've talked about arc length. That's kind of the mathy version. of this, the mathese of it. In a circle, the ratio of the length of a given arc to the circumference. That's this right here. That's what we've got our arc length over 360. Okay, times 2 pi r. That's the formula we're using. That's the length of the arc. So the measure of the arc over 360 times 2 pi r is the length of our arc. Remember, measure is your degree, length is your linear measurement. All right. Any questions there? Yeah.
I was wondering whether or not our homework is in the book.
Part of it will be in the book. I have a plan. Yeah, man. Okay, we're going to come back to radians here in a minute. All right. I want you guys to take a look at page 318. This part of your homework is in the book. The other part I will hand to you. All right. So right now, doing, huh? No, you keep your other book for now. We'll use it later in the year. We won't use this book for a long time this year. Okay? Right now, I want you guys to complete 1 through 5. Okay, work with your partner. Page 318, 1 through 5. Okay, so a couple of good questions. First, diameter of circle with the circumference. Well, if you're given circumference, and you know circumference and diameter has a relation of circumference is pi d, well, I can use this information and plug it in and solve for d. Now, how do I solve for d there? Yeah, if I want to get d alone, I've got to divide both sides by pi. So 10 over pi is equal to d. Now, I want your answer in terms of pi. So there's at least 2 people that I looked at your paper a minute ago, and you're not paying attention now, and you didn't have your answer in terms of pi. You just had decimal. So I want it in terms of pi, and I want in decimal.
Rounded to the nearest
Okay.
100.
Rounded to the nearest 100. Yeah.
Is that every time?
Yeah, let's go every time, round to the nearest 100. So 3.18 inches. Okay? All right, questions there? Okay, keep working through them. It's good questions. Keep asking the questions. Okay, circumference with a radius of 3. So circumference and radius relate with this formula. So if the radius is 3, (6 pi) or 18.85 centimeters. Three in terms of pi? You can't. Which one is 3?
Can you like
Right here?
8 equals 2 pi r, and then figure out get r by itself?
So in this one you're
Or
putting in your 2 pi r,
yeah, that's right.
and the circumference is 8.
Divide by 2.
Yeah, you actually divide by, you want to get rid of the 2 and the pi, right? So it's like a package deal. Divide by both of them.
Oh, I only divide by 2, and then I divide by pi after that.
And that would work also. So you get 4 over pi.
Yes. Oh, okay.
I'm out of
yeah,
room
I
there.
was right. I just did
I have to write that over here.
extra.
4 over pi equals r, which is 7.54. I think. Isn't it? No? Oh, no, that doesn't make sense. Yeah, 4, that'd be like 1.28. 27?
Yeah. Because it's 1.27.
All right. 1.27 feet of ruse.
Where'd you learn your math?
From my math teacher. All right. Chase.
So number 5.
Yeah.
Just round it up to 5%.
No, let's talk about number 5. Let me finish number 4 real quick. I know you guys are cruising right along here. So this is pi d. That gives me 2.4 pi, which is approximately 7.54. And make sure we're putting our labels, right? Meters. Okay. Any questions on 1 through 4? So Chase, you're asking on this one, if we're figuring our degree measure, or what part of the circle is, what is it over 360? Yes, 70. Okay? So 70 over 360 times our circumference, 2 pi r. 2 pi times 3. Okay? 70 360 is reduced. We just cancel out the 10 there. So that's 7 over 36 times 6 pi. You guys with me there? Okay? And so if we do that now, we can cross cancel or cross reduce. A lot of you make more sense with that. So cancel that. That's 1 and that's 6. Becomes 7 pi over 6 inches. And then we round that to 3.66 inches. Is it 6.6 or 6.7? 3.665. That would be a 7 then, yeah. Okay. Okay. Any questions on that? Last piece. Rather than having degrees, we also have radians. Now, I'm going to describe radians to you real quick. Everyone take a look at radians here. In a circle, now don't let these things confuse you here. Okay? But in a circle, you have 360 degrees. If you take a radius of a circle and line it up around the outer edge of that circle. So like if I took this radius and started lining it up on the outside, in a half a circle, I get about 3.14 radiuses that go around. Now 3.14 should sound familiar. Yeah, that's pi. Okay? In fact, if I keep going around a circle, no matter how big the circle is, because as the size of the circle increases, its radius increases proportionally. Okay, as I keep going around, in fact, in a whole circle, I have 6.28 radiuses. So a radian is how many radiuses it takes to measure. How many of those, like if I took the radius and cut it out and line it up on the outer edge, how many radii it takes to measure around. Okay, that's a radian. So rather than measuring in degrees, we measure in radians. And in fact, 2 pi, remember 2 pi is 6.28. Okay, 1 pi is 3.24. So in 180 degrees, or a half a circle, or 3.14, excuse me. My goodness. I'm rushing here. Okay, so in a half a circle, that's 3.14, or 180 degrees. Full circle, it's 360, or 6.28. So you have a proportion you can do. If I were to tell you I have 60 degrees, so looking back at page 318, if I have 60 degrees and I want to know how many radians that is, in other words, how many radii that is, this is why I kept using 2 pi r earlier. I know that there are 2 pi radians, so I dropped the r, but the r, like radiuses, 2 pi radians in 360 degrees. So I am comparing radians to degrees. Everyone with me? So if I want to know how many radians I have in 60 degrees, I'm going to set up the proportion. There's 60, and this, I don't know how many radians, so that's x. Now, how do I solve a proportion? Cross multiply. That is 120 pi equals 360 x. Then I divide by 360. I get 120 pi over 360, which reduces to, we cancel the zeros, 1236 is 1/3, or 1/4. No, 1/3. My goodness. 1/3 pi. And we usually write that as 1 pi over 3. So pi over 3. In fact, next year when you're in advanced algebra, you'll be using that measurement a ton. In fact, you're learning about radians before the trig kids are. We usually don't teach this in geometry.
Oh.
Nice. So you'll know something. You go, ha, I know something you don't know. Okay? All right. Any questions there? Kind of weird. Let's try this one. Set up your proportion. If I have 2 pi over 360, that's equal to what? Well, in this case, my radians are 5 pi over 6. Now that seems weird because you're putting it in a fraction. You're making a compound fraction over x degrees. 2 pi x, cross multiply. And then 360 times 5 pi. 360 times 5 pi. What's 360 times 5? 1,800 divided by 6. 300. 300 pi.
Yeah. Wait.
Right? We multiply by 5 and then divide it by 6. Divide each side by 2 pi. We get x equals 150. All right.